welcome to this tech tip. Today we wanted to show you optimal binning in IBM SPSS statistics. My name is Astrid Cook and I'm an analyst here at version 1. So what is optimal binning? Well, it's a technique that automatically converts a continuous variable into categories that are closely related to a target outcome. So it will create bins for scale variables using a categorical guide. So suppose you have the data below. We have the satisfaction score, and would you recommend us? You could choose to break the satisfaction score into categories. With optimal binning, SPSS analyzes the relationship with recommend us and finds the cut points that best separate the yes and the no groups. Optimal binning has several benefits. First of all, it can find the best categories automatically, so it will find the cut points that best separate target groups. It also removes guesswork. So instead of choosing category boundaries yourself, a user can use a guide variable to determine categories. It can improve predictive modeling results. It makes results easier to explain. Continuous variables can be turned into meaningful business-friendly groups. It can create categorical variables when they're needed. So this can be useful when you want to run an analysis that requires categorical inputs or categorical predictor variables. Also, you can reuse the rules. So SPSS can save the binning rules and apply them to future data sets. Now, to get started, go to the Transform menu and select Optimal Binning. You'll choose the variables you want to bin. Here, I want to bin satisfaction and response time, and I want to optimize the bins with respect to willingness to recommend. When I click on the Output tab, I'll ask for endpoints. I can also ask for descriptive statistics and model entropy. Now, model entropy is a measure of the predictive accuracy of each variable with respect to the guide variable. You can click on Save and create variables that contained binned data values. So these are the new binned variables that will appear in your data set. Then you can save binning rules as syntax. If you click on missing values, you can select pairwise or listwise. Now, under options, you've got pre-processing, so you can pre-bin variables to improve performance with large data sets. You can manage sparsely populated bins. You can adjust bin endpoints. And of course, for the lowest bin and the highest bin, you can choose unbounded or bounded by lowest data value or bounded by highest data value. So here I've done a comparison. I've run two models predicting whether or not customers would recommend us. I've used satisfaction and response time as my predictors or my independent variables. Now, in the first model, I used the original variables, and the overall accuracy in the test data set was 81%. We can see satisfaction importance and response time importance. Now compare these results to after optimal binning. So here I'm using the new binned variables. You can see that overall accuracy in the test data set increases to 86%. We also see that satisfaction bin importance is now much greater than response time bin importance. So the optimally binned variables produce a more accurate model and made it clear which variable was driving predictions. So let's see how this works in IBM SPSS statistics. Now to get started, I'll go to the Transform menu, come down to Optimal Binning, and this brings up the dialog box. So on the Variables tab, I'll select the variables that I want to bin, so satisfaction and response time. And then recommend is what I want to predict. So I'm going to ask to optimize bins with respect to recommend. I'll click on Output. I can ask for descriptive statistics and model entropy. I can click on the Save button. I do want to create variables in the data set. For missing values, I'll make my selection here. And for options, I want to have bounded by lowest data value for my lowest value and bounded by the highest data value. And when I'm ready, I'll just click OK and run the procedure. In our output, we'll have the table of descriptive statistics at the top. So we can see the count we can see minimum and maximum values on satisfaction and response time, and we can see the number of distinct values as well as the number of bins. Beneath this, we can see model entropy. Now, there is a note here that lets me know that smaller model entropy indicates higher predictive accuracy of the bin variable on the guide variable recommend, and we can see that satisfaction has the smaller model entropy. Beneath that, we've got the binning summary. Now, you'll be able to see the bins, so bin 1, 2, and 3, and you can see the cut points that are selected are 59 and 83. Now, for the moment, let's just look at bin 1. 372 respondents would not recommend, 28 would. And what that means is 93% of bin 1 respondents would not recommend. In bin 2, by contrast, 129 said no, but 221 said yes. So this means that 63% of bin 2 respondents would recommend. So what we're seeing is how optimal binning helps us pull out those that would and would not recommend in satisfaction scores. Beneath that, you can see response time as well. Here, if we look at each bin and we look at those who would recommend, with greater response time, you see the numbers of those who would recommend decrease. Finally, the new variables are created in the data set. So here we have satisfaction bin, and then we have response time bin. So it will create for you those new bin variables that you can use in further analyses. So that's everything we wanted to show you today. If you want more information on IBM SPSS statistics, you can visit our website at www.spssanalyticspartner.com. So thanks for watching, and bye for now.